Hello, welcome all. Today we'll be discussing about the data structures and algorithms. Initially, I'm starting the topic of traversal of binary tree. You already know what is a binary tree. Let's just brief the concept of a binary tree before traversal. Now, let me take a very simple binary tree. Now, what is a binary tree? A binary tree is any tree that has either 0 or 1 or 2 children. They doesn't have more than 2 children. So example of a binary tree. So let me consider the topmost node as root. This will be the root node. And the nodes, as I told you, binary tree can either have 0 or 1 or 2 children. Now let me take that my root node has 2 children. So this is an example for a binary tree. If I want to grow my binary tree further, I can either add one child or I can leave as such so that this node doesn't have a child at all, or this node can have two more childs. So let me introduce the concept of one child. So my tree has one child, this node, and the other node is having two child. So there are two childs. Now this is a binary tree. If you see, this doesn't make it as a binary tree because this specific node is having three nodes, that is three children, which is not acceptable in binary tree. Now, this makes a perfect example of a binary tree. Now, these are the nodes. So obviously when I start the binary tree's traversal, where traversal is nothing but traversal is one of the operations that can be performed on binary tree, which is nothing but visiting the nodes, visiting every node at least once. So visiting nodes once. So you cannot visit a node twice or thrice because that happens only in graph, not in the binary tree. Because binary tree should not have cycles. That is one of the characteristics of trees. Now, let me consider the traversals. So traversal of this binary tree, obviously traversal starts from the root because we doesn't know where these nodes are stored. Suppose if I store this complete tree in the form of a linked list, how it would be stored, but before that let me add the items info so it would be easy for you to understand. So let this be B1, B2 and C1, C2 and C3. If I change this binary tree in the form of a linked list representation, the binary trees can be represented either in linked list representation or with the help of a array. If you have any doubts on such kind of representation, please comment on the video. So I would be presenting a next video based on it. So let me take the linked list representation directly. Obviously, I need a node for this item to be stored. So you must have seen in linked list that we are storing node value in a node. So I would be getting a node from the free. So I will get a node from the free and I'll break them into two, where I'll place the info here and I'll store the address of the left child here and I'll store the address of the right child here. This is its representation, and the left child is this and the right child is this. Now, as we had begin in linked list, there should also be a pointer. So let me name the pointer as root. So what does this root stores? This stores the address of the root node. So as you can see that I will not know the address of the nodes, that is of B1 and B2 or C1, C2, C3. I'll be just knowing the address of the node, that is A, nothing but the root node. So my traversal always starts from root. That is the point which you have to understand it. So now let us move on with the traversal. Traversal. So before I move on with the traversal, I would like to show what are the different ways we can traverse. So the first type is going to be pre-order traversal. The second type is going to be in order traversal. The third type is going to be post order traversal. Now, these are the three types of traversal which you guys can use for traversing a binary tree. Now, let me just move on with the pre-order traversal first. So, what is a pre-order traversal? Now, pre-order traversal, as we have seen about the prefix notation where we used to write the operator first, here I will be writing the root first. So the first node that I will be traversing is the root. And after traversing the root, I have to move on with the left subtree, and then I have to move towards the right subtree. So as you can see, we are not going on with the left and the right node. We are moving on with the left subtree and the right subtree. This is pre-order. So let us take an example. Let me take a very simple example. So let me take this as a root node, and let me have two child for the root node. So this is going to be B1 and this is B2. And let me take two childs for this node, again C1 and C2. And let me take the right child for this node as C3. So as you can note, B2 does not have a left child. It is possible, as I told you, binary tree can have either 0, 1 or 2 children. And you can see C1, C2, C3 are not having children. So these nodes are called as a leaf nodes, which is acceptable in the binary tree. Now, let me do the pre-order. As I had told you, pre-order, the first thing we will traverse is root. So as I told you earlier, I can start the traversal from the root, which means I have traversed this node, the root node. So you see, this node is traversed. And after traversing this root node, which way I have to give? Either left or the right. So as you can see, pre-order is nothing but the left subtree. So which is nothing but I have to go to the left side first and not the right side. So the left side, if I come again, it is again what? B1, where B1 is nothing but what? A root of this subtree, which you are going to have from the main tree. So as you can see, from the left subtree, again I am having a root. So B1. So the next it's going to be B1. So B1 creates again two subtrees. One, this is left subtree and this is right subtree. Again, which way I have to move on? The left subtree. So again from the left subtree, if you see C1, it's the only node in the left subtree of B1. So therefore, C1 will be traversed. And once C1 is traversed, which node I have to go? I have to go to the right subtree. So which is nothing but C2 will be traversed. So next node to be traversed is the right, that is C2. So if you look closely, I have completed the left subtree of this node A. Now when I have completed the root A and I have completed the left subtree of root A, so what's the next thing I have to do? I have to start with the right subtree of A. So which is nothing but this section. Now if you see in the right subtree, again where I have to go to the root. So right subtree's next node is nothing but B2, which is again a root. So B2 will be traversed. After B2 is traversed, again the same thing, the left subtree and the right subtree. As you can notice, B2 doesn't have the left subtree, so there is no way that I have to move with the left subtree. So I have to go till which position? To the right subtree. So the right subtree is nothing but the C3. The C3 is traversed. So as you can see, the traversal, the pre-order traversal of the binary tree is nothing but A, B1, C1, C2, B2 and C3. That's all folks. This is the video of pre-order traversal of a binary tree. If you have any doubts, please comment on the video and don't forget to subscribe, since it would be a best idea for creating further videos and solving your doubts. Thank you.